Okay, we've talked about how sound is just wiggling and how the wiggling moves the air molecules and it moves our eardrums, and how different speeds of wiggle are different pitches, and varying intensity of wiggle is varying volume of wiggle or loudness. But the one thing we haven't talked about with sound is what defines one sound from another, which is to say, when you hear a saxophone playing a note and then you hear a piano play that exact same note at the exact same volume, it still sounds different. So there's one other element we need to talk about, and that's timbre or tone color. What differentiates one sound from another? And I know I told you sound was simple, but this part of sound is a little bit complex. But it's complex in the sense that it's a lot of simple stacked on top of a lot of simple to make complex. Here's what I'm talking about. Okay, remember how we had the ruler, and we flicked the ruler was moving up and down, and that's what was making it sound, and it was making this movement? Well, this is kind of a simplification, because the ruler is actually moving in more ways than just the up and down movement. As the ruler is moving, the ruler itself is fluctuating as it's moving up and down. So what you have is the waveform that is the wiggle that's happening within the ruler, and then the waveform that is the ruler moving up and down. And it gets more complex than that. The ruler is also moving in even more different ways than just what I can do with my hand. And all of those different ways that that ruler is moving, it's really undulating. And all of those different movements are also bumping into air molecules. And the air molecules are carrying those vibrations to our ear too. And what happens is our eardrum doesn't actually differentiate between all of those different vibrations that are happening inside that ruler. Our eardrum just hears that as the sum of all of those vibrations. And then we say, oh, that's the sound that a ruler makes, because our brain apparently has the ability to identify these summed piles of wiggles. Let's move on to like a string, like a guitar string or a violin string. To demonstrate the wiggles that I'm talking about, let's just look at the string itself. When you pluck the string, the whole string moves up and down. That is the frequency we hear. And that's the fundamental. So if you pluck a guitar string, a G string on a guitar, you're going to hear G. But that string is moving in a lot of different ways that are not G. And here's how. So the fundamental is that G, and that's the main up and down wiggle. But that string is also wiggling as if you'd cut it in half. So as it's moving up and down, it's also moving in a way that has divided that string in half. But that's not the only way that string is vibrating. The string is also vibrating as if it were cut into three. And all of those wiggles are creating a different frequency at a different amplitude, which is to say a different note at a different loudness. But basically, we hear the fundamental. And then all of these other wiggles that are happening on top of the fundamental, we don't hear as frequencies. We hear the combination of them as timbre.